Have you ever wondered how Google finds information so quickly, even among billions of web pages? The secret is smart algorithms. Today, we're going to learn one of the fastest searching algorithms, binary search. Let's get started. Binary search is an algorithm used to find an element in a sorted array. Instead of checking every number one by one, binary search repeatedly divides the search area into two halves. That's why it's much faster than linear search. Binary search explained. Introduction. Imagine you have a phone book with 10 lakh names. If you search every name one by one, it will take a lot of time. This method is called linear search. But what if I told you there's a much faster way? That's where binary search comes in. In linear search, we check each element one by one until we find the target. For example, if we want to find 15 in this array, 2, 5, 8, 12, 15, 20, 30. We check 2 cross, 5 cross, 8 cross, 12 cross, 15, check mark. It works, but it's slow for large amounts of data. Instead of checking every element, binary search cuts the search space into half, again and again. Let's see how it works. Imagine we have the following sorted numbers: 2, 5, 8, 12, 15, 20, 30. Our goal is to find 15. Step 1, look at the middle number. The middle number is 12. Since 15 is greater than 12, we ignore the left half. Now we only search 5, 20, 30. Again, look at the middle. The middle number is 20. Since 15 is smaller than 20, we ignore the right half. Now only one number is left. 15. Target found. Instead of checking all 7 numbers, we found the answer in just 3 comparisons. That's the power of binary search. Here's the Python code. Def binary underscore search, open parenthesis, r, comma, target. Close parenthesis, colon, left equals 0, right equals len. Open parenthesis, r, close parenthesis, minus 1 while left, less than or equal to right colon, mid equals open parenthesis left, plus, right, close parenthesis slash 2. If r, open, bracket, mid close bracket equals target, colon return mid, if r, open bracket, mid, close bracket, less than target colon, left equals mid, plus 1, else colon, right equals mid, minus 1. Return, minus 1. The algorithm keeps checking the middle element. If the target is larger, it searches the right half. If the target is smaller, it searches the left half. Every step cuts the search space into half. Because of this, time complexity is O of log n. This makes binary search much faster than linear search, which takes O of n time. Binary search is used in many real-world applications, searching contacts in a sorted phone book, finding words in a dictionary, database indexing, software libraries, search engines. Whenever data is sorted, binary search becomes an excellent choice. Today, you learned what binary search is, how it works, its Python implementation, its time complexity, its real-world applications. If you found this video helpful, don't forget to like, subscribe, and share it.